So far, we have seen what is standard normal distribution and how to calculate the G-score, and why the standard normal distribution is widely used in statistical analysis. So now we're going to explore about the z-test. So where the z-test is applicable, and on which variable z-test is applicable, and what type of distribution it uses, and how do we calculate the z-test or z-score or z-test statistic, and how do we decide the level of significance, how do you calculate the probability, and how do you decide, or how do you select a feature using a z-test. So the everything we will discuss in this. So the same pattern will be applied to will also be applied to F test and chi-square test and t-test and QCase HST test also. Let's begin with our first question. Which test statistic does it use? The z-test uses the Z statistic or Z score as the test statistic. The Z statistic is calculated by taking the difference between the sample mean and the population mean or hypothesized population mean divided by standard deviation of the sampling distribution, which further divided by square root of n, which is your sample size. So x bar is the mean of the sample, mu is the mean of the population or hypothesized mean of the population, sigma standard deviation of the sampling distribution, and square root of n is number of observations, and sigma divided by square root of n is called sampling error of sampling distribution. Okay, so this is how we calculate z score or z statistic. The term z statistic or z test statistic are often used interchangeably and refers to the same concept. The z statistic or z test statistic represents the standardized value obtained in a z test, which is a statistical test that uses the standard normal distribution, or also known as a z distribution, as the reference distribution. For z test, what do we use is a z statistic, and this is how we calculate. So what's next? The next question is, which distribution does it use? Z test uses standard normal distribution, also known as z distribution. Either we call it as a standard normal distribution, or simply we say z distribution as the reference distribution. So the distribution has a mean of 0 and a standard deviation of 1. So the whatever z statistic that you get, you will mark it on your z distribution, and from that you will get to know what's the probability of getting that, whatever way you say, what is the probability of that is happening. So with that probability you can compare with the significance level, and then we can decide whether to go with that feature or not. Okay, so that's the next question. It has been answered, and the third question is, which type of level of measurement or variables this test is applicable. This is also very important. So this z test is applicable when dealing with continuous variables and when the population standard deviation is known. So it's often used when the sample size is large, typically n greater than 30. You have to remember that. Typically n greater than 30, as uh, the test is based on the central limit theorem. So that's where the z test is applicable. So one is continuous variable, and second one is uh, when the population of the when the population standard deviation is known, or else if you have a enough sample size, a bigger sample size, which it should be greater than 30. Okay, normally that's possible. So the fourth question that we have is, which table does it use to calculate the probability? Very important one. So you got the z-score. So then how do you calculate the probability of that happening? So that's probabilities. The z-test does not directly use a specific table to calculate the probabilities. Instead, probabilities can be obtained by referring to the standard normal distribution or z distribution table, or by using a statistical software or programming libraries that provide a functions to calculate the probabilities based on the z distribution. But here in this case, we won't be using tables. We will be using the libraries from Python, such as scipy, basically stats module. Okay, so and that's what the next question, it's been answered. And the fifth question, so most of the things has been answered. You will calculate the z statistic, and that you will take z distribution as a reference. Then it will be applicable to the continuous variables where the sample size is greater than 30. And uh, to calculate the probability, we will be using the z distribution. Majorly we'll be using some libraries. So now the fifth question is, what Python libraries that support doing z tests? So one is the scipy.stats module provides the z-score function to calculate the z-scores. Once you calculate the z-score, then we can use a z-test function in the stats module. Stat models, this is a different library. Scipy is a different library. You can get z-score from scipy library, and z-test function from stats models.stats.weight stats module performs z-test for one sample and two sample cases. And this is where you bring the libraries. So the final question, which is, how is this test performed? Very important. How is this test performed in totality? Because we have seen all dependencies and what is z test, and then surrounding ecosystem. So now you know everything about this. Now is this how is z test performed? So first one, state the null hypothesis and alternative hypothesis. Collect a sample and calculate the sample mean and the standard deviation. Determine the population mean under the null hypothesis. Calculate the z-score using the formula z is equal to sample mean minus population mean divided by population standard deviation divided by square root of sample size. And then find the corresponding p-value, that's a probability value, associated with the z-score using the standard normal distribution. Then compare the p-value to the predetermined significance level, usually 0.05, to make a decision regarding the null hypothesis. If the p-value is less than the significance level, the null hypothesis is rejected in favor of the alternative hypothesis, indicating the statistical significance.